Welcome to May's Leetcode Challenge. Today's problem is ambiguous coordinates. We had some two-dimensional coordinates like 1, 3 or 2, 0.5. Then we removed all commas, decimal points, and spaces and ended up with a string S. Return a list of strings representing all possibilities for what our original coordinates could have been. So our original representation never had any extraneous zeros, so we can't have numbers like 00, 0.0, 0.00, 1.0, basically anything that can be represented in a more simple way. We don't have any numbers like that. So also a decimal point within a number never occurs without at least one digit occurring before it. So we won't have numbers like 0.1. We'll have to have at least 0.1 or 1.1, whatever. Now the final answer can be returned in any order. That's good. Also note all coordinates in the final answer have exactly one space between them, meaning the space right here, but okay, whatever. So if we're given like 1, 2, 3 as an example, like how many possible ways can we divide this up? Well, we can solve this like pretty straightforwardly. There's no real trick. It's just a matter of how we can figure out whether the numbers are valid or not. So what we'll do is first think about where the comma can exist. Now the comma has to be either right here or right here, right? So after we have that, we have, well, here we have two distinct possibilities, but we also need to figure out for each one of these numbers, how many possibilities are there with this. So like here, with 1, there's only 1, but with 2, 3, we might have 2, 3, or we might have 2.3. So we're gonna have to have like a nested for loop inside. Let's start off by first simplifying our string because it has an open and closed parentheses. So what we'll do is just say, I get the let's see, from 1 to -1, and that should give us just 1, 2, 3 here. Okay, now we want to get the length of the string, and we want to do a for loop. So for I in range of 1 through n, we want to figure out where we put the commas, right? And here I'm just going to divide it up in two numbers. We have the a and b. The a is going to be s of up to the I, and b is going to be what? S from I to the end, right? So let's just print out the a and b and make sure this looks right as well. And there we go. We have like 1, 2, 3, or 1, 2, 3. Right now we have to figure out how many different numbers can we make from these numbers each, right? So we'll have to do a nested for loop, and we'll say, okay, for first in, and I'm going to write a helper method here. I'm going to call it unpack and say, return to me a list of all the possible numbers where we can put a decimal point in between somewhere. And we'll do the same thing here for second in unpack b. And we basically just need to append to some sort of output the possible strings here, all the possible combinations. So output append, and I'm going to use string format. I'll just say, let's see, we have this, and we're going to have two numbers. So we'll say format first, second. Okay, so now the key is to figure out how we can unpack this number up with all the decimal points in there. And this is where it gets tricky, but if we at first, I tried to use like a converting to a float and then back to a string, and I had some success with it, but unfortunately, because of the scientific notation, that brought a lot of problems. So unfortunately, I had to look up some answers and see how other people did it. Basically, there's two steps here. The first is to see if the number itself we can add to, if it's valid without any decimal point in between at all. So without decimal point, like, how can we figure out if it's okay or not? And I'm also going to get the length of n here. Okay, so without the decimal point, if there's going to be two conditions we have to check for, like if the x of let's see, if the very beginning does not equal 0, then we can definitely append. Because no matter what it is, as long as there's not a 0 in front, we know that this number is valid. But we also need to, if it's just a 0, that would also count. So if x, the first number does not equal 0, or x equals 0 itself, then we can append it to our list here. So we'll say append the x. Okay, now we want to check to see all the decimal points in between. So for I in range of 1 through n, we are going to check if we could put a decimal in between here. And there's basically the main thing we need to figure out is like from, let's see, x -1, as long as, okay, first this can't equal 0, the very last digit. If we want to put a decimal point in between and it ends with 0, that doesn't make any sense because we can simplify that. And we also need to check if the very, like, if up to the certain point equals 0 here, or x of 0 does not equal 0. If these conditions fit, then we can add our candidate, which would be what? Let's see, x to the I plus period plus x from I onward, right? And we can append this candidate to our temp. Now finally, we can return our temp here, and that should give us all the possible decimal numbers that we can have, as well as no decimal one, and then we'll just add that to our output, and then we turn the output once we're finished here. All right, so let me see if this works. Okay, that does look like it's working, so let's submit it. Oh no, okay. Oh, okay. I made that mistake before, so let's try that again. Okay, what am I messing up here? 1, 3, 12, 3. Oh, I guess it's just a space that they're concerned about. Yeah, there we go. Okay, so that was just a silly error with the space right there. But the real hard part I found, like everything else I was able to get on my own, but it was this condition here to figure out how can we check to see if this number can be simplified in decimal format. So this works. You know, it's kind of unintuitive, and I think, yeah, I mean, whatever, it works. So I definitely took some research to figure this out, but hey, I'm sure there's some other methods. But yeah, that's the basic approach. So yeah, I think I'll just end it here. Thanks for watching my channel. Remember, do not trust me. I know nothing.